Okay, so question 11 is a show that, but I mean, although it's helpful to know what the answer is, so you know when you've got it right, it's not necessarily helpful to help us out here, but that's okay, we can do it. So here we're going to get down to x and then nothing, a constant of 1 by integrating the cos part. So cos 2x we know goes sine 2x but divided by 2, and then we're going to keep the x squared minus, so we've got the over 2, the sine 2x over 2, and now we're going to differentiate the x squared, so it becomes 2x. So I'm going to put the 2 out the front and just have the x there. Okay, and that is all, we're still doing 0 to pi. So I'm going to do 0 to pi here. Okay, now when I put in sine of 2 pi, I've got 0. When I put in sine of 0, I get 0. Also, there's the 0 squared if I sub it in there. So that first bracket's going to get us 0. All right, minus, here we've got 2 on 2, so it's just 1. Okay, so we've got the integral of sine 2x x. So again, I'm going to take that sine x and integrate it. Now when we get integrate sine x, this time I get minus. So this is sine 2x. It goes to negative cos 2x over 2. And we're going to keep the x minus the integral of minus, so that can become plus, cos 2x over 2. So I'll put that over here. And we're going to differentiate the x, so you get 1 dx. All right, so again, I shouldn't have put that there. So just remember that if I just get rid of that, put that x back in there, so that was times by x. So this minus out the very front here is for the whole block, if that makes sense. So actually I've got positive for this bit, positive, and for this bit negative. So if I go back to positive here, I've just got cos 2x divided by 2 times x, and I'm doing that between 0 and pi, and here I've got plus a half, and now I can, oh sorry, minus a half after I've just said that. There we go, minus a half. And now I'm going to integrate cos 2x, so I get sine 2x over 2. So sine 2x over 2, and that is between 0 and pi. All right, so what have we got here? We've got, if I just put that half out the front, when I put the pi in, I get pi times cos 2 pi. Cos 2 pi is 1. So I get pi times 1, so that's pi. When I put the 0 in, it doesn't matter what I get because it's times 0 there, so minus 0. Over here we've got, why have I got a positive? I've decided it's a positive, and I'm not sure why, so I think I've done something wrong, but let's just leave that for the moment. So I'm going to get sine 2 pi, I put the 2 outside, so it becomes a quarter. I'm going to get a sine 2 pi, which is 0, and a sine 0, which is a 0, so it doesn't really matter either way. I'm getting a 0. Nice. Okay, so I'm going to end up with just pi on 2. Is that what we wanted? 11a. Yep, that's what we wanted. Thank goodness. Okay, so let's try with b. So for b, all right, so again, for b, I'm going to integrate sine x on 2. Now, when we integrate our sine x on 2, we've got our cos x on 2, but we're dividing by that a half, so that means timesing by 2. And when we go from sine to cos, we need a negative, so we've got negative 2 cos of x on 2, and then I'm just going to leave the other one, which was x squared. Okay, so we've got that one between 0 and pi. Now we'd go minus, and if I put it all in, we've got minus 2 cos x on 2, and then we're going to differentiate x squared. So that becomes 2x dx. So because it's 2, I'm going to make that front 4. And it's a minus minus, so that's going to become a plus. Okay, and that's 0 to pi. All right, so let's go back to this one here. All right, so when I put 0 in, obviously I'm timesing by 0 squared, so that's 0. When I put the pi in, I've got cos pi on 2, which is 0 as well. So that whole first bracket is giving me 0. Okay, so what do I have for cos x on 2 times x? Well, again, I'm going to integrate cos x on 2. So let's put the 4 out the front. Cos x on 2 goes to sin x on 2, but we have to divide by a half, which is 2, timesing by 2, and I'm leaving the x there, minus, I need the 2 sin x on 2, and this time I'm differentiating the x, so I just get the 1, so that's all nice. All right, so actually here I've got 8 sin x on 2 times x between 0 and pi. And you can see here I've got minus 8. Minus 8. The integral of a sine x on 2. So I get, again, a minus because I'm going to a cos x on 2. And I have to divide by 1 on 2. So I get a 2 there. All right. Hopefully that's so easy to make a mistake here. So when I sub in 0 here, obviously it's times 0, so I don't have to worry about that. When I sub in the pi, sine pi on 2, sine 90 is 1, and I'm timesing by pi, so I just get pi there. Here I've got, I'm going to put the 2 outside, so I've got positive 16. Now, when I sub in pi, I've got cos pi on 2, which is 0. When I sub in 0, cos of 0 is 1. So you can see here I'm going to get the 8 pi, and I'm going to get minus 16. Let's hope again. That's what we wanted, thank goodness. All right, so let's do it again. Let's try with C. So remember to stop and try it yourself. Make sure you can pick up any of my errors for me. All right, so let's look at C. So we've got a sine of a log x here. So, you know, that's a little bit tricky. There's not really 2 terms there. So if I just put a 1 in front, I'm going to integrate the 1. So I'm going to get x, and then I'm going to leave sine log x there, minus, so x was the part I integrated. Now, differentiating sine log x, that's always fun. So sine, we know, goes to cos when we differentiate. Then we're going to go inside and differentiate log x, and I get 1 on x dx. Now this is all between 1 and e. Okay, so this one here, if I put e in first, I get e sine of log base e of e is just 1, so sine 1, minus 1 sine log base e of 1 is 0, so that's actually just 0. All right, minus, so here I'm back to 1 to e of cos log x dx. So yeah, so we can go again with that one. Let me just simplify this one. So this is e sine 1. So 1 sine 0 is just 0. All right, so we're going minus. So again, I'm going to kind of put another 1 in there and integrate that 1. So I've got x, and I'm going to leave the cos log x, minus. So the integral was, the integrated part was x, and now I'm going to differentiate cos log x. So cos goes to negative sine, right? So I'm going to put the negative at the front, so negative sine log x, and go inside and differentiate the log x. I get 1 on x. And that is between, 1 and e. All right, so really I've left the 1 and e off. So here's e sine 1 minus, if I just do this little bit in here, between, if I sub e in, I get log base e of e again here, so I get cos of 1, so I get e cos 1, e cos 1, and if I do 1, I get 1 cos 0. 1 cos 0. And just be careful here, I've got a minus times a positive. So that'll be a negative. So I've got negative, the integral, and it just becomes sine log of x dx, which was our original integral. So actually I can add it to the other side and say now I've got two lots of the integrals. I've got e sine 1, I've got minus e cos 1, cos of 0 is 1, so I've got a plus 1 there. Yeah, because this is minus times minus. Alright, so I've got plus 1, and I've already put that integral on the other side. So to find the answer for that actual integral, I'm going to divide by 2. So I'm actually going to factorize by e at the same time as dividing by 2. So I'm going to get sine 1 minus cos 1, and then I've got to divide this by 2 as well. So plus a half. That gives me the answer I'm looking for. Excellent. Alright, so let's do it. Pretty much the same thing for D. Same thing for D, but this time we're starting with a cos. So I'm putting a 1 in front. So my integral is going to equal x, and then I'm leaving cos log x where it is, and minus. So I've integrated the x part, I'm differentiating the cos part, so cos goes to minus sine log x times 1 on x dx. Oh, I keep putting 0 in, there we go. Alright, when we sub e in, we get e cos 1 minus, and then we've got 1 cos 0. Got minus minus was a plus. So here we're integrating, I'll put the 1 in. So 1 times sine log x dx between 1 and e. Alright, so we know cos 0 is 1, so this is our e cos 1, that's an e minus 1. Now here again we're going to do our by parts, so I'm going to integrate the 1 and leave the sine log x minus, so I've integrated the 1 and I'm going to differentiate sine log x, so sine goes to cos log x times 1 on x dx. And that's between 1 and e, so e cos 1 minus 1. Alright, when I sub in the e, I get e sine log base e of e is 1, minus, when I sub the 1 in, I get 1 sine 0, and we know that's 0. Alright, and then you've got minus this integral from 1 to e of cos log x. Now that hopefully was our original integral, so we can add it to the other side and say two lots of the integral gives us e cos 1 minus 1 plus e sine 1, plus e sine 1, and then we know sine 0 is 0. Alright, so we again factorize by the two terms with e and divide by the 2. So we've got cos 1 plus sine 1, and then we've got minus a half. Hopefully, yep, that's what we're looking for. Excellent. Hope that helps.